Hi, I'm the math guy Steve. Let's try solving this equation. So in solving logarithmic equations, if everything has a log, then we can make log equal to log and then set the insides equal to arguments equal. Whereas here, if everything doesn't have a log, let's try to change it to an exponential equation. So here, let's try to first get log equal to a number to change to exponential, meaning we have to get these to be one log on one side. So let's, if there's a plus in between and these two logs have the same base, then we can multiply their insides or their arguments, meaning this becomes log base 6 of x plus 4 times x plus 3 equals 1, okay? And now we change it to an exponential, okay? So change the exponential, we do what's called the circular motion, okay? So start from the base and then make the circular motion. So we start from 6 to the 1 equals this inside, meaning that gives us, okay, 6 to the 1 equals, and if I multiply this inside, we just multiply that, foil it out, okay? What you put on your baked potato, right? Foil, okay. Multiplying that out, we get, so x times x, we get x squared plus 3x plus 4x plus 12. Okay. And now it's a quadratic equation. We know how to solve those, right? So getting 0 on one side, we get 0 equals x squared plus 7x. And then subtracting 6, we get plus 6. Okay. And so now, get 0 on one side, now we factor the other side. This right-hand side, we can factor by double bubble. Okay. X and x, And numbers that multiply to give me 6, add to give me 7. So that's positive 6 and positive 1. Okay. And so now we set each factor equal to 0. X plus 6 equals 0. And x plus 1 equals 0. So x equals negative 6 and x equals negative 1. So that would be our two solutions to this equation. Now, here's the thing. When we have logarithmic equations, we definitely have to check it, okay? Because sometimes we get extraneous solutions, okay? So let's try to check it. That's called the Nike step. Check step. Let's do it. All right, so let's check it. So if I plug in negative 6, we get log base 6 of negative 6 plus 4 plus log base 6 of negative 6 plus 3. Is that equal to 1? Well, remember, one of our rules of logs is the argument can't be negative. So here we get a log base 6 of negative 2. Again, that's an extraneous solution. Whereas if we're plugging negative 1, we get here log base 6 of negative 1 plus 4 plus log base 6 of negative 1 plus 3. Is that equal to 1? Well, our arguments now become log base 6 of 3 plus log base 6 of 2. Is that equal to 1? Remember, one of the properties of logs, they have the same base. We can multiply their insides, right? So this becomes log base 6 of 6. Is that equal to 1? And now, again, another property of log, which says if it's log base 6 of 6 to the 1 power, this left-hand side just equals 1. So yes, 1 equals 1. So again, when solving logarithmic equations, try to get log equal to log. If not, then get log equal to a number so we can change to exponential. And it's a lot easier equation to solve. And don't forget that Nike step, that check step, okay? Always remember, math is everywhere.